Klang Valley, or Greater Kuala Lumpur, one of the fastest growing metropolitan cities in the world. Home to 7 million people, this city is notorious for its traffic jams.
Jam kat KL ni daripada dulu sampai sekarang memang sama je lah. Rasanya tak ada kesudahan, memang jam je.
In Kuala Lumpur, every day is a jam day.
The city is growing faster than its infrastructure can support. A solution is desperately needed.
It was just absolutely necessary for us to build a mass rapid transit in Klang Valley. We didn't think there was any other option.
The Sungai Buloh Kajang line will traverse 51 kilometers across the valley, with 9.5 kilometers underneath the city center. 10 tunnel boring machines will excavate through rock and soil to build the tunnel walls. 6 machines are designed specially for Kuala Lumpur's challenging geological conditions.
You can say it's very special because no machine has been designed like this before.
State-of-the-art trains will stop at 31 new stations, each designed to reflect Malaysia's rich heritage. Greater Kuala Lumpur needs this more than ever. But can Malaysian engineers rise to the challenge? Klang Valley, Malaysia, also known as the Greater Kuala Lumpur, is one of the fastest growing metropolitan cities in the world. In 2010, the Malaysian government initiated the Economic Transformation Program to elevate Malaysia into a developed nation by the year 2020.
The Economic Transformation Program, the objective of the program is really to transform the economy of Malaysia to become a high-income economy that is inclusive, at the same time sustainable.
Part of this initiative is to transform the Klang Valley into a world-class city and a globally recognized economic hub.
We realized that cities compete much more vigorously than nations. And so if our city is not as competitive, we have a problem with attracting capital into the city. And we might have a problem attracting talent as well, and trade and businesses. So that's why we focus on that.
But being home to some 7 million people with an expected increase to 10 million by 2020, this city is notorious for its traffic congestions. Every day, about 2 million cars enter the city center. Traffic experts have predicted that the city will be in perpetual gridlock unless drastic measures are taken to reduce vehicular traffic on the roads.
Memang jam. Mana-mana kita pergi pun jam. Saya paling lama tersangkut dalam trafik jam ni lebih kurang 1 jam lebih. Distance dia lebih kurang 3 km macam tu.
Malaysia desperately needs a new transportation model that will change the infrastructure landscape of the Klang Valley. In 2010, the government implemented a project that will be the catalyst for this change, the Klang Valley Mass Rapid Transit, or KVMRT. This rail network will form the backbone of a new sustainable transport system, integrating with existing transport infrastructure, such as the LRT, monorail, KTMB commuter, intra-city and intercity bus routes. Not only will the KVMRT gear the Klang Valley towards the standards of other global cities by enhancing the connectivity, it will also improve the environment of Greater Kuala Lumpur.
We are aiming to have at least 40% of the people using urban public transport. That's going to take a lot of cars off the road, and which means it will reduce emission, and that will clean the air greatly for Klang Valley.
In July 2011, the Prime Minister of Malaysia, Datuk Sri Najib Tun Razak, launched the biggest infrastructure project ever undertaken. It was his vision to improve the connectivity within the Klang Valley and radically enrich the lives of the people. MRT Corporation Sendirian Berhad was formed under the Ministry of Finance, with Datuk Wira Azhar Abdul Hamid helming the position of the CEO to execute the government's mandate to complete the KVMRT project by 2020.
As owner-developer of the MRT project, what we're doing is we're making sure that, of course, this project gets built and delivered on time. The idea here, is not just to build an MRT, but in doing so, what we're also trying to do is we're trying to influence landscapes in Kuala Lumpur, as well as try to change the way of life of citizens in Kuala Lumpur.
The KVMRT's first alignment is the Sungai Buloh Kajang line. It is a corridor with a population of 1.2 million people.
We embarked on a very detailed study, and we found that this was the least served areas as far as rail transportation was concerned. So that was why we gave priority to actually undertaking the Sungai Buloh Kajang rail alignment.
With the construction of this 51-kilometre line with 31 stations, residents will be able to travel between populated residential districts, commercial centres and key employment areas within the Klang Valley. The KVMRT project will play a vital role in creating a vibrant Klang Valley metropolis. Not only will it benefit its residents, but also propel the nation's economy with immense spillover effects on sectors such as the construction and construction-related industries. But constructing a new transport system in the Klang Valley is not an easy task. The line traverses through densely populated areas.
The city was not planned enough to accommodate the high growth in population and the high growth in development. That's why we have all this problem with finding a corridor to accommodate this kind of large-scale mass transportation system.
The 51-kilometre line is divided into the elevated section and the underground section. For the first time in Malaysia, the concept of a Project Delivery Partner or PDP was introduced to manage the construction of the elevated section of this highly complex project.
We transfer the risk of project delivery and the risk of making sure that there are no cost overruns as far as the project is concerned. It's transferred over to our PDP.
The PDP basically will be responsible for managing all aspects of the project. That means the design aspect, the procurement aspect, and also the implementation or the construction aspect of it. Bottom line is, PDP has to ensure that it delivers what it's supposed to do, which is delivers according to the targeted cost and also delivers according to the completion dates.
To ensure the success of this project, a strict procurement process was implemented to award a total of 85 work packages. Companies were subjected to stringent evaluations to ensure that only the best and most experienced contractors were selected.
The idea is for the government to appoint contractors, to award packages to capable local contractors. For our civil infrastructure works, we have 10 of them. For systems, we have 13 of them. The contractors carry out the works, and the PDP manage the contractors.
The government set a target of 43% of the value of all contract for the MRT Sungai Buloh Kajang line to be awarded to Bumiputra companies.
To date, I think we've exceeded that. We are now about 45, 46%. And we're making sure that this sort of support as far as the Bumiputra agenda is concerned will be sustained in the future.
A special MRT Exco committee was also set up to ensure that this project moves swiftly and smoothly.
Undertaking a project like the MRT, we touch many government departments and ministries. And for us to actually spend time to go to them one by one is going to be very tedious. Now, with this committee that is basically chaired by the Chief Secretary to the government, a lot of decisions can be made on the spot with everybody present. So, in a way, it makes our job a lot easier. And I think the MRT model actually has been enhanced by having this MRT Exco.
To ensure that the cost remains manageable, land acquisitions were kept to the minimum.
The government has asked us to make sure that at least 70% of it is government reserve so that we don't encroach too much. So we try to keep the land acquisition or the compulsory acquisition level down.
We have had to share reserves with some other infrastructure, for example. And we had also tried to put this alignment where there are public roads or public highways. So it was quite a challenge to achieve that.
At the underground section of the line, mutual agreements were drawn up between MRT Corp and individual landowners.
We're talking about people's private property that they've acquired to the generation from their father or grandfather, and there's a lot of emotion attached to owning this sort of properties. So we try to not acquire them, but with a lot of guidance and with a lot of support from people like the Attorney General's chambers. Our team, together with the PDP team, we've managed to craft out a unique mutual agreement for each lot that you land title that you actually want to work with. End of the day, what happens is you can coexist and these property owners don't lose their land. And this is the beauty of it. We are allowed to build our tunnel underground with the property owners still enjoying their property.
The above-ground section of the MRT consists of elevated viaducts and stations. 1,400 numbers of piers are being constructed to support 17,000 segmental box girders. At the peak of construction, about 20 400-ton launching gantries are used to build the viaducts.
Because we're building all these structures for the MRT line through heavily congested area. So we've had to do a lot of pre-planning, actually. Plan for the traffic diversion and the construction to be done in stages. So we call it phase construction. So we will divert traffic to this side in phase 1, finish works here, and then divert to traffic to this side in phase 2, and so on and so forth.
The close proximities to existing structures also makes construction of the elevated sections more difficult.
Certain areas we are not able to use conventional machines because to build this kind of structures requires very huge machines like the ones you can see over there. Those are the type of machines that we use for the foundation work. So we get areas like what we have in this vicinity, like in Semantan and Pusat Bandar Damansara, where we've had to resort to non-conventional method. Things like hendak caissons, which are basically foundation piles but constructed by hand digging. It's a very labor-intensive kind of work, but we can't use any other method because it would be too dangerous because of its proximity to buildings or its proximity to major roads, like in this particular case, and also because of safety to the public.
To avoid adverse impact to the city landscape, buildings and roads, a part of the Sungai Buloh Kajang line in the city centre is underground. The underground section is 9.5 kilometres long and stretches from Semantan to Maluri, while passing through 7 underground stations: KL Central, Pasar Seni, Merdeka, Bukit Bintang, Pasar Rakyat, Cochrane and Maluri. To build the tunnel boring machines or TBMs are used to excavate rock and soil with special tools fixed on a rotating cutter head, while building permanent walls at the same time. To meet the tight program, 10 machines are used.
Tunnel boring machines are essentially cutting tools for the ground. You can refer to them as a mole. Most cities now, for railway, the tunnels are built using TBMs because of safety issues and because of ground conditions.
Overall, the ground conditions along Sungai Buloh Kajang line underground section consist of the Kenny Hill Formation and the Kuala Lumpur Limestone Formation.
The Kenny Hill Formation is actually consists of weathered sandstone or mudstone. So it is very predictable and the profile is very consistent.
For this section, 4 conventional earth pressure balanced TBMs are used.
KL Karstic Limestone Formation is one of the most difficult ground conditions for tunneling in the world. It consists of cavities, fissures, underground passages, so you can imagine that you are tunneling through a very unknown condition. So from the experience that we learned from SMART, we sent our team to Germany to work with our supplier to develop a machine capable of handling this type of situation, which is now known as the variable density TBM, and it is the first of its kind in the world.
The new machine, called the Variable Density TBM, was a result of a combined initiative by Malaysian tunneling experts from MMC Gamuda and Herrenknecht of Germany.
It's a product of ideas, opinions and experience from all quarters. It's a very comprehensive machine. You can say it's very special because no machine has been designed like this before.
This TBM was designed with safety in mind.
I think far more important is the safety that it brings to not just the people but the property on the route. When we deal with karstic limestones and we find solution chambers and cavities that could actually cause mini collapses, or the ground subsidence could bring some neighboring structures down. This way at least we are saving millions in terms of protecting this property, and that I think is far more important in terms of safety.
6 variable density TBMs are used to tunnel in the difficult karstic Kuala Lumpur limestone formation. But before the TBMs can mine, the launching sites need to be prepared first at Cochrane, Inai, Pudu and Semantan. The Cochrane Station site has the largest construction footprint, which measures about 14 acres. 4 TBMs have been launched from here. Work started on site in May 2012.
Some of the stations are being built from the bottom-up construction method. Here we will excavate to the lowest level and build upwards.
Controlled rock blasting was employed to excavate the shaft down to a depth of 30 meters.
Blasting itself is a very dangerous activity. So definitely there is no room for even the slightest mistake. Therefore, the safety measures need to be followed strictly throughout the whole process. And second is to control the vibration and sound to the allowable limit, so that it will not induce any damage to the surrounding building.
Excavation of the shaft took approximately 9 months to complete. The first variable density TBM arrived in Malaysia in late January 2013. Transporting the TBMs to the sites through Kuala Lumpur was a challenge that needed detailed coordination. Precise planning was required for the assembly of the machine, as any damage would require custom repairs in Germany.
This is a very complicated machine, and we are also dealing with very delicate components, very heavy, looks very tough but very delicate. We cannot afford to damage it. If the extent of damage is huge, then the impact to the project will be tremendous.
At the Inai shaft, 2 variable density TBMs have been launched. The circular shaft was excavated to a depth of 34 meters. At the bottom of the shaft, chambers were dug to allow for the assembly of the TBM. Due to the tight space conditions, lowering the parts of the TBM was extremely challenging, especially the screw conveyor.
It's the most difficult one because this length is actually bigger than the shaft itself. It's 18 meters long. The shaft is 17 meters. Any damages caused to this component would cause a major setback to the project and definitely to our launching.
The launch of the first variable density TBM was officiated by the Prime Minister of Malaysia, Datuk Sri Najib Tun Razak, on 30th May 2013.
Dan hari ini kita dapat menyaksikan pencapaian yang bermakna dalam perjalanan negara kita. Bukan saja untuk melakukan perubahan yang besar kepada sistem pengangkutan awam negara, tetapi signifikan projek MRT ini untuk Malaysia ditransformasikan sebagai negara berpendapatan.
The TBM is equipped to both excavate and build tunnel rings, which form the lining of the tunnel. Each ring consists of 7 segments and 1 keystone. Segments weigh up to 2.2 metric tons and are lifted by a vacuum system. The ring builder controls the giant hydraulic arms of the erector to position the segments down to millimeter precision. A total of 11,500 rings are needed to line the dual 9.5-kilometer tunnels. Tunnel walls need to be strong enough to withstand extreme pressure and chemical attacks from the ground and water, and to also endure settlement caused by poor ground conditions. The tunnel segments are manufactured off-site at 3 different factories.
We are adopting the technology what we call steel fiber reinforced concrete. We use a staple-like steel fiber to replace a conventional thick and heavy rebar. On top of that, we are using another fiber called polypropylene fiber to improve the fire-resistant properties of our segments.
At certain stretches of the tunnel where reinforcement is required, segments which can withstand extra load were designed.
What you can see here is the hybrid system. When I said hybrid system, means we'll have this rebar in, and at the same time we'll pour in steel fiber reinforced concrete to cater special geological conditions like crossing Sungai Kerayong or for the Stack Tunnel.
The segments are transported to the TBM using multi-service vehicles. As the TBM mines deeper into the ground, the temperature and humidity rises further. Giant fans pump cool air into the ventilation duct that stretches all the way to the TBM. The tunnel is like a giant artery feeding the men and machine with vital supplies, cool air, power, water, grout, and a crucial material, bentonite slurry. This thick grey liquid plays an important role in the variable density machine. It keeps pressure on the rock face and acts as a protective coating to the giant drill as it grinds forward.
Variable density machine, as the name suggests, the machine is capable of varying the slurry density at the excavation chamber of this machine. It actually prevents the blowout to the surface when we use the sufficient pressure to counteract the existing ground and water pressure. In the normal slurry density, the same pressure is going to push this slurry all the way up to the surface, especially in shallow condition. And secondly, with the high viscosity, we slow down the losses of bentonite in the very cast condition in the limestone. In the normal slurry machine, the slurry will lose out so fast, we will be delayed in the machine's response in injecting sufficient slurry back to counteract the losses.
The slurry also carries the mined waste out of the tunnel. Above the ground, a massive slurry plant is working around the clock to process and clean the slurry coming from the TBM through a series of screens.
What the separation plant has to do is to ensure that the screens are all working perfectly, there is no clogging in the screens, and to make sure that all the conditions of the motors and also the screens are in 100% good condition.
The cleaned recycled slurry is then piped back underground via giant pumps to the TBM to start its journey all over again. After mining for a certain distance, the TBMs need to stop for servicing and maintenance, and this is called an intervention.
We're having this intervention stop to have a check on the cutter discs. Cutter discs are like the knives of the machine that cut through the ground. So we're just going to check whether we need to change them or not so that we can further mine.
The cutter head lies in the forward pressure zone. Before any work can be carried out, tunnel engineers first need to determine whether the ground conditions in front of the cutter head is safe.
The first thing I'll be concerned with is the pressure in the front. Before the men go inside and do this maintenance, we have to make sure that the pressure is okay in the front.
The TBM's cutter head is armed with 37 tungsten carbide discs that cut through the rock and soil. After mining a certain distance, the cutter discs have worn down and need to be replaced.
We already finished the inspection for the cutter head. So we found only one disc and one knife bucket have to change. So now we do the preparation for the changing.
Inside the cutter head chamber are some of the worst conditions a tunneler can face. There's barely any space to move and the temperature can rise to 45 degrees Celsius. To make matters worse, each cutter disc weighs about 200 kilograms and can only be hoisted using chain blocks.
It's certainly not the best space to work at. It's very hot, very stuffy, and you can't really hear because it's too noisy in the front.
An hour later, the new cutter disc is in place and the TBM is ready to mine again.
Okay.
More than 1,000 people are working on the construction of the underground section. MMC Gamuda has a dynamic team of Malaysian engineers with leading roles.
I have great opportunity to work in and manage jobs in smart project, the Berapit Tunnel, and now this one. Every job, the responsibility and opportunity is expanding exponentially. I think it's a good challenge and I appreciate this kind of opportunities.
I'm now handling one of the machine and running the full operation of the tunnel. I am lucky because I have good mentors teaching me how to actually control the machine, how to actually manage the people. It's quite challenging, but I think I like it because there's not many chances that you can be in a tunneling construction industry.
It's a great challenge for me every day, but I'm looking forward for what I'll be learning next. Most of us are young engineers. We learn from scratch. We grow together with our team. But today, I believe we are strong enough to continue our journey.
MMC Gamuda has also invested in the Tunnelling Training Academy, which was officially launched by former Prime Minister of Malaysia, Tun Dr. Mahathir Mohamad, in December 2011. The first of its kind in the world, this academy aims to develop a highly skilled Malaysian workforce who are proficient in the specialized field of tunnel construction and can undertake world-class engineering projects. To date, some 500 professional and skilled workers have been trained in various fields to support the tunnel and underground construction works, in particular for the KVMRT project.
Sebab benda ni mesin baru, banyak benda yang kita kena belajar. Engineer dan senior banyak tunjuk ajar kat saya daripada mula sampai sekarang lah. Dah faham pasal TBM ni. Bagi pendapat saya, masa depan kerja dalam tunneling ni agak cerah lah sebab ni baru first project MRT. Mungkin lepas ni ada lagi.
Saya bekerja di TBM, saya diberi tugas jaga piping belakang. Saya rasa bangga dapat bekerja di projek terbesar di Malaysia.
I always believe that the future of Malaysia is always related to our human talent. And so these guys training on tunneling work is fantastic because there is a lot more application, not just in Malaysia but elsewhere. And so if we finish all the work here, and that experience they've had will bring tremendous revenue for them as individuals in their career beyond Malaysia.
Recently, the Academy received global recognition when MMC Gamuda signed a Memorandum of Agreement with the Delhi Metro Rail Corporation Limited. This MOA outlined a strategic collaboration between the two companies, where engineers from the Delhi Metro Rail will be sent for customized theoretical and practical tunneling courses at the Academy.
We are proud that not only we are able to set up a tunnel training academy to train Malaysian, but we also be able to train people from abroad.
To ensure the safety of the underground construction workers, emergency drills are carried out regularly at the sites.
We want to ensure that the emergency response team is always prepared and ready in the event that a real emergency happens.
The emergency response team are also trained for fire rescue in a tunnel.
Our team members, at least 200 staff in our UG's area, need to be trained to know everything if the fires goes on at their workplace, so they know what to do.
This training gives them first-hand experience of when not to put themselves at risk.
A risk assessment and mitigation team also carries out detailed planning and works in advance to ensure that the TBM passage does not cause any danger to existing structures.
We are preparing the way for TBM before the TBM arrive. For instance, their piles need to be removed, their soft ground needs to be strengthened. So in a way, we are paving a smooth way for the TBM to go through to avoid any subsidence or any structural deformation.
On the surface, where underground works are ongoing, survey teams monitor for any movement or ground settlements. Regardless of whether it's private or public property, the teams are on a constant lookout for signs so that immediate action can be taken.
This monitoring works is basically you get to monitor the effects and the impact of our TBM drive, which will be passing by here, on the structures above, on the surface above.
But the Kuala Lumpur karstic is unpredictable. Even with all the measures taken to protect the surface above the mining works, ground depressions can still happen.
Tonight we have a sinkhole. The sinkhole is actually right in the end of the Jalan Bukit Bintang, directly on top of the TBM.
The TBM has stopped mining. A boulder is stuck in the screw conveyor, and the tunneling team are trying to solve the problem as quickly as possible.
We have closed one direction of the Bukit Bintang road. We need to fill this up and get this sorted out, repaired, get the machine passed, and we want to open the road and get everything to normal as soon as possible.
To ensure minimal inconvenience during the construction, an extensive traffic management plan is implemented. This ensures minimal lane closures and diversions during peak hours, and the advance information is given to the public.
Because we are passing through very densely populated areas and very heavily trafficked roads, we have had to embark on very detailed traffic management planning to ensure that all the work areas are cordoned off properly with the objective of minimizing the impact on the road users and also ensuring that the motorists are able to travel through the work zones safely.
Building KVMRT potentially touches every person living within the Klang Valley. An effective PR and communications team is ever ready to interact with the public and stakeholders. These engagement programs help the project in receiving support and cooperation from the public.
MRT Corporation and PDP, we take a lot of effort to make sure that we engage all stakeholders. It's important for people to understand what we're trying to do. And it's also important for people to understand how we are going to impact on their lives, and also giving them the opportunity to voice their concerns to us. And the public has certainly voiced some of their concerns to us. And it is for us to respond to these concerns, to make sure that everything is managed well and everybody is treated fairly.
The first prototype of the train was recently unveiled in Kuala Lumpur to the public.
The design of the train was actually done by BMW, working together with Siemens. We've incorporated a lot of safety facilities as far as the train is concerned.
Its 3.1-meter width is among the widest in the world and will be able to carry 1,200 passengers. The trains are designed to run at intervals of less than 2 minutes, and the expected daily ridership is about 400,000 passengers. The design of the elevated stations share a particular theme: the Malay Wakaf, a traditional shelter for travellers. It will be a micro-public plaza, a light and airy pavilion. The underground stations will use a multifaceted quad stone as the unifying theme. Each station will also highlight special elements from its location.
We have 7 different underground stations. These are in very distinct part of Kuala Lumpur. An example is we have one station located where the Warisan Merdeka development is going to be done. In that particular station, we have the Merdeka theme, where we incorporate features like the Rukun Negara and also pictures of Merdeka. We have another location, which is at the TRX. So there is a financial feature. At the end of the day, we want to make this fun as well, something that people can relate to.
On 24th April 2014, the underground team celebrated their 5th TBM breakthrough, accomplishing more than 50% of the underground works.
If you look at the progress so far, it's been extremely encouraging. And my congratulations to Gamuda for working, with Haruknek to actually come up with this TBM. And I think with what has been going on with the breakthroughs that we've been having, I think it's been worth their while, and it's really paying off. We've brought the underground work to a very good pace, and it's testimony to all the hard work that's been put in by the team.
It has been a tremendous, unforgettable journey. The machine has performed very well. So, combination of machine equipment and good people, our engineering crew, our operation crew, the academy boys, and our young graduate engineers that have performed all beyond par. It is an incredible achievement, not only for me, but for the whole team, for the whole project.
Compared to SMART, we only got 2 incidents, whereby in the same length in SMART of almost 7.5 kilometers, we have 41 sinkhole. So I would say that we are happy that the machine have performed more than expected.
The 95% reduction in sinkholes compared to the construction of the SMART tunnel proves the effectiveness of the new and innovative variable density TBM.
I think more and more people will look to this experience we have here because it's state-of-the-art. We are doing piloting, we're doing something completely new here. That's frontier technology in its application, and that's a feather in the cap for Malaysia.
As of July 2014, construction progress for the first KVMRT line is advancing at full speed, with major works underway at various stages.
At the moment, as far as the overall progress of the project is concerned, we are at about 47%. We're happy with the progress that we've made, and we're slightly ahead of plan, and we are still committed to delivering the date that we originally set before we started to do the physical work.
Once completed, the new KVMRT will change the landscape of Greater Kuala Lumpur. It will radically improve the city's transportation coverage and propel Kuala Lumpur into one of the most livable cities in the world.
I see the MRT project as a game changer. We're creating new destinations. We are creating new ways of life. I believe with the full development of good rail infrastructure in Kuala Lumpur, the people will understand that all the pain and all the inconvenience that they felt before is worth their while. For the next generation, they may not feel the pain, but they will certainly be enjoying the gain. So it can only be positive.
The one dream that everyone has is to make sure that we have Greater Kuala Lumpur as a competitive and very livable city by the year 2020. And I think this is one project that I believe has a thumbs up all around.